value. In Khartoum state here, we have tremendous amounts of sewage sludge. Tons of sewage sludge are being dumped in Khartoum state, either in Khartoum or in Khartoum North, and they don't know where to take these wastes. So we use these wastes and we recycle it we recycle these wastes in the soil for improvement of soil quality. Also, I concentrate in my research on using water hyacinths from the White Nile. We collect these water hyacinths and we process it and we recycle it in the soil. Also, in Khartoum state, we have tremendous amounts of wastes from vegetables. This is this photo from Omdurman market, vegetable market. They have lots of vegetables that are, they don't know where to dump these wastes. So I try to make use of these wastes and we recycle it in the soil. And we believe that what has been taken from the soil should come back to the soil for sustaining soil fertility. And this is actually excluding the part that we eat. Waste, so why we recycle waste? Waste is the characterization of waste. Waste has got or is characterized by a high percentage of nutrients that can be added to the soil. For example, agricultural waste contains 0.6 to 2.9% nitrogen, and 2% nitrogen is a high percent, mostly obtained from legumes and cakes. It has got also a considerable amount of phosphorus, although phosphorus in agricultural waste is not too big, and also contains high concentration of potassium, and potassium in agricultural soils in Sudan is not mainly necessary because vegetable soils, they have high concentration of potassium. So we recycle that in sandy soil. When we come to sewage sludge has got high percentage of nitrogen. So most, or globally, people, they concentrate on use of sewage sludge, but careful use of sewage sludge. The bagasse has got a 0.2 to 1.8% nitrogen, and water hyacinths from the river Nile also has got high percent of nitrogen that can be recycled in the soil. Waste has got its positive effect as and also has got negative effect. The positive effect of waste concentrates on improvement of soil quality, and improving soil quality will definitely improve crops yields, and that I will come to it later on. The main negative effects of waste is concentrated on one is known one is known as allelopathy, and allelopathy is allelochemicals. It's known that when you recycle some agricultural waste, when they decompose, they excrete or they release some chemicals that are known to be allelopathic to the subsequent crop. It decreases or it retards or it it stops in sometimes germination of the succeeding crop. If it does not reduce germination, it reduces seedling establishment, and this allelopathy is actually coming from allelochemicals, and this is known in Agadi scheme, where they practice zero tillage. They leave the crop residues on the soil after harvesting the edible part, and they just leave that on top of the soil, and then when the rainy season comes, these crop residues, they decompose, and then some crop residues, but not all, they contain or they release allelochemicals that are detrimental to the succeeding crop. How far or how long do these allelochemicals last in the soil? This is another picture or another research. Some wastes, when you recycle them in the soil, they decrease yield. They decrease crop yield, and this is mainly due to immobilization of mainly nitrogen. And this is this phenomenon is actually proved when you recycle bagasse, when you recycle crop residues with high carbon to nitrogen ratio. When there is a high carbon in the residues or in the waste being applied to the soil, this carbon is used as an energy for organisms. They proliferate, they increase in number, and they look for nitrogen. And if the recycled material is characterized by low nitrogen, then these organisms, they go and look for nitrogen from around the rhizosphere or the rooting system, and then they take out the nitrogen for build of them themselves, and that's why the crop will suffer from nitrogen immobilization, and the crop will suffer from establishment and yield reduction. So we have to be very careful in managing crop residues or waste with high CN ratios. Some wastes, and especially effluents from factories and also sewage sludge, municipal sewage sludge, they contain some concentrations of heavy metals like cadmium, lead, and arsenic. And these, if they accumulate in the soil, they are carcinogenic. So we have to be also very careful in managing these waste. Waste application in nutrient-poor desert soils. This is my line. I recycle this waste for improvement of poor sandy soils or poor desert soils. I mainly light soils and sandy soils. They are poor in their habit. They are poor in their phenomena. They are poor chemically, physically, and biologically. So we recycle this waste for their improvement. This shows you how do we apply these wastes. We either apply waste to the soil directly as fresh. That means it's not composted. Composted means when you bring the waste and you make composting or you compost the waste so that to stabilize this waste. This experiment is carried out in Western Omdurman in a highly desertified soil, where we made compost of water hyacinths and banana waste and other waste, farmyard, and you can see this is the picture of the waste in midway. Here also, during the composting process, we monitor. It's not only composting process, we monitor the temperature. This is how we can monitor the temperature in the waste until the temperature of the waste equilibrates the air temperature. When we compost the waste, the temperature increases gradually, and then it stabilizes, and then it comes down, it's decreasing, until the ambient temperature equilibrates the temperature of the waste. Then we stop composting, and then we decide that the composting process is complete and we have a finished compost. This is also composting processes from Khartoum waste. They dump the waste. They make, they take out the inner materials. They remove out all parts that are not being composted, and this is the final compost that we recycle in the soil. This is also another type of crop waste, another method of incorporation of agricultural waste, and this is a PhD student who is incorporate the crop residues after harvesting. This also an experiment that we conducted in the River Nile state, where we recycled bagasse, banana waste, in the soil for improvement of these poor sandy soils. Okay, after we recycle this waste in the soil, what's going to happen in the soil? What's going to happen to the waste? I study the behavior of the waste in the soil. I should know each waste has got its own behavior in the soil, according to what I say later. After we apply the waste in the soil, the decomposition process starts. It's a physical breakdown and biochemical transformation of a complex organic molecules of dead material into simpler organic and inorganic molecules. The waste is going to be transformed in these things. These carbon chains with varying amounts of attached oxygen, hydrogen, nitrogen, phosphorus, and sulfur are the basis for both simple sugars, amino acids, and plant nutrients. Decomposition of organic matter is it's a biological process. What decomposed waste in the soil? The waste in the soil does not stay like this, like its initial stage. It starts decomposition, and the main factor for decomposition is microorganisms. So it's mainly a biological process. It depends on biotic and abiotic factors. And biotic factors and abiotic factors, I will explain them later on. Soil organisms, the physical environment, moisture and temperature, and the quality of the organic matter. Okay. After what we study during decomposition, the results of the decomposition is going to be fitted to a model. And mainly we use two types of model to describe the decomposition of waste in the soil. We use the exponential model, the single exponential models, and the double exponential model. The model actually shows you how this waste decomposed in the soil. And from this model, we calculate W naught, which is the potential amount of the waste that's decomposable. And K is the rate. This K is the rate constant, and it's minus because it decreases. It starts with 100% and then it decreases. The behavior of the model, or the shape of the model, varies from waste to waste, from within waste, from environment to environment, and it depends on many factors. This actually we studied in a period of time. Some waste they take 1 year to attain 10% remaining part. The factors that we put in the model is the amount remain, the loss, the weight loss, and the nutrients release. Another model we use it in describing this process of decomposition is the double exponential model. And the double exponential model, as I said, some waste, when they decompose in the soil, they do not decompose in a one phase. We find some waste have two phases of decomposition. This is the first phase of decomposition, and this is the second phase. Mainly the first phase of decomposition describes the loss of easily decomposable materials like the sugars, the amino acids, the sugars, the highly soluble organic materials, they are being lost rapidly in one phase. And the second phase is known as the phase where there is a slow release, slow decay, slow decomposition. So that's why in this model we have two rates of decomposition, and the rate is loss per unit time. Normally, the rate of phase 1 is more than phase 2. Okay, so what we look into the soil? Actually, when we put the material in the soil, we study this decomposition, or we monitor the behavior of this material using two types of methodologies. The first methodology is known as the litter bag method. And in the litter bag method, we enclose the material in a mesh, and these meshes are being spread on the soil surface or incorporated. And both methods, they have different behavior. Another method of studying decomposition, another methodology, is the lysimeters. We put the waste on top, and when we fix the soil columns inside the soil and put the material, and then we monitor weekly or 2 weeks the amounts being released, either weight loss or nutrients. Some wastes are resistant to decomposition, and this is caused by high levels of lignin, phenolic acids, or even active polyphenols. We found that polyphenols, total polyphenols, they counteract the decomposition or the release of the nitrogen from the organic material while decomposition. And not only the total polyphenols, but the active polyphenols. The polyphenols are materials that engulf or they chelate the nitrogen, and therefore increasing their physical resistance or decreasing the accessibility of this nitrogen during grazing by microorganisms. And also it depends on the results in the longer periods of soil protection and carbon-nitrogen ratio. This shows you the K. This K, the rate, this is one of the findings of my research, the decay rate, or the weight loss during decomposition. You will find that these are the materials, and this is the decomposition rate percent per unit time. You will find that it's quite different. All these materials are very different in their release or in their decomposition. If you look into carefully, the first two are crop residues, maize and groundnut. They have different decomposition rate constants, but the lower the rates are in blank and in black. They are very low, but of different types: the mahogany, the mango leaves, the guava leaves. So I work on crop residues from the field crop residues, and vegetable crops, fruit crops, forest crops, and water hyacinths. You will find that why these are very different, and these only two are high. Although this is maize, this is groundnut, and groundnut is a legume, and leucaena is a legume, and this is 0.5% per week, and this is 9% per week. These two crop residues are their decomposition was on the humid tropics, where conditions are highly favorable for decomposition, and the rest of the materials were carried out in the semi-arid tropics of Sudan. That's where the environment is not favorable enough for speedy decomposition. After we get the results, I will show you some of the results. This is different types. This is the guava and the mango, and this is the percent remaining potassium, percent remaining nitrogen, and percent remaining phosphorus, percent remaining calcium, and each of them, they look different, quite different in terms of losses. These are fruit crops, and these are forest crops. This is water hyacinths, and these are feed crops. You will see that the potassium, more generally, the potassium is being lost. The only nutrient that's being lost rapidly from decomposing materials is potassium. In a week, 90% of the potassium is being lost. Therefore, for example, because potassium is non-structured element in the plant leaves, if you bring any vegetable, and if you soak this vegetable in water for some time, like for example when we soak ureuca in a bucket of water, and if we leave that for say half an hour, we will lose 90% of the potassium. And this is okay. Soaking is okay because we are going to lose the nitrate. And it's good also to soak vegetables in the water before we eat, so that we lose the nitrate, because the nitrate, when it comes inside the digestive system, it's during processing, it's going to be converted into an organic material that is carcinogenic. So that's why nitrate, concentration of nitrate is very important in edible parts and even in drinking water. Sometimes you'll find bottles of drinking water, they write all the nutrients, but they exclude the nitrate. And this is actually the bullshit. You have to write the nitrate. After, these are the results. After we bring the results of the decomposition, we try to make correlations, and we want to know the best parameter that describe or that fit or describe the best correlation between loss of either mass or a nutrient with its characterization. What are the best parameters we use to correlate the cellulose, the lignin, the total nitrogen, the pH of the soil, the polyphenols, and lots of correlation, so that we can come into parameters that best describe these things. Okay. A very important managing waste, we concentrate on what's known as synchrony. My research concentrates on the best time that we apply the waste, so that the period here, it's time? The period here, oh yeah, I started, just give me 10 minutes. This is the maximum period. We call it the maximum period where it shows the release of the nutrient, and mainly we concentrate on nitrogen. And this is the maximum period where the demand by the crop. Simply, we want to bring the food, just like bringing the food to the person at the time that he's hungry. If there is any, if there is no coincidence between the two, they will be lost. So if this peak of release does not match the peak of demand, then there will be a build-up of a nutrient, which is most possibly the nitrate and the ammonium. There will be build-up of this nutrient in the absence of its uptake. So this high concentration will give chances for losses, either to the atmosphere, or in terms of ammonia, or to the underground water in terms of nitrate, and both are pollution of the environment. So my research concentrates on the best time of applying these weights for high matchability between application, between demand and supply. We study the waste in the soil. We also try to study what happened in the soil. We study the chemical changes, the physical changes, and the biological changes. This is what we study. This is the physical changes. We study the shear strength. We study the soil resistance in the soil. And also we study what's known as the palm size fractions, particulate organic matter fractions, the different types of fractions, small and the medium fine sand fraction, the coarse sand fractions, and the medium sand fractions. These things are going to build in the soil, and this will improve the quality of soils. We run after improving or increasing these quantities of small brown parts. These are organic materials that improve the quality of the soil in terms of physical, chemical, and biological. We also studied infiltration rate, and if you see that combination of fertilizer and crop residues improve infiltration rate. I think I should go a little bit faster. Also, when you apply waste in the soil, there is an increase in microbial biomass, and this is very important because microbial biomass, they bring about the composition of materials. They bring about chelation of heavy metals. This shows you the organic matter increase, and also the organic matter fractions, the coarse, the fine. Most organic matter fractions, they concentrate on the fine particles. Also, I studied soil enzymes, and I found that soil enzymes in the rain-fed are mostly higher than in the irrigated schemes. This is a study that I carried out in Germany, and samples from the Gadarif and from the Jazeera scheme. In the crop studies, I study the yield, the nutrients uptake, and even the rooting system. This is a PhD experiment, and you can see the yield of this wheat crop in the northern state. You see this is red in the bagasse. So recycling bagasse, it decreases greatly the amount of yield because of, as I said earlier, of immobilization. And you see the water hyacinths, recycling the water hyacinths improved greatly the yield, followed by the banana waste. And this is also in Western Druman. You see that in the first wheat, second crop wheat, third crop wheat, and you see that the yield in the black, the black is always combining crop residues with fertilizer gives you the best performance. And this is in the sandy soils, sorghum in the sandy soils. See the chicken manure. And also in my studies also, I studied the fate of nutrients from this waste using M15 tracing technique. And you will find that the percentage, I also try to find, to distribute the fertilizer between the plant and the soil. And you find that the one in green is the plant part, and most of the fertilizer remained in the soil. This is using M15 tracing technique. This is also using M15 tracing technique, tracing the nutrients in the crop residues. And also I calculate what's known as sustainability, and this index I use sustainable yield index, and sustainable yield index is equal to y minus s over y maximum, where y is estimated average, and the standard deviation, and y the maximum yield. And this is what I obtained, sustainable yield index after 3 seasons. When you recycle crop residues, I was able to get 40% of sustainability using crop residues, while in the control there is only 21%. I also concentrate in other side of my studies in salt-affected soils, and these are so interesting. I concentrate on improving sodic soils. In western, I mean in the southern part of Khartoum state, we have considerable areas of sodic soils. These sodic soils, they contain sodium, and sodium is detrimental to the soil, and we try to knock out the sodium and replace it by calcium. And we can only use gypsum for improvement of these sodic soils, for knocking out the sodium. But actually gypsum is now there is a competition between factories and agriculture and people. And factories, they buy the the gypsum, and we leave sodic soils without remediation. But in the southern part of Khartoum state, sodic soils, they contain calcite, calcareous, but this calcite is not soluble. So I formulated a hypothesis that can I use this inherited calcium carbonate in the soil of sodic soils, and can I solubilize this using phytoremediation? In my background, that legumes, when they fix nitrogen, they pump out hydrogen. So if a legume is able to tolerate sodic soils, they can pump out hydrogen, and this hydrogen solubilize the calcium carbonate and release the calcium, and then this calcium can knock out the sodium. And actually, I put out this hypothesis, and this shows you how the thing works. And also, this is the calcite, shows you how the calcite can be solubilized using hydrogen protons from a legume that fixed nitrogen. Therefore, I formulated this hypothesis, and I took with me 10 seeds from Jazeera scheme, and I did this experiment in UK in 2009 when I stayed there for 1 year, and I was able to get an amazing result. This shows you I was able to prove that what's known as lubiafin, or this is hyacinth bean. Hyacinth bean was able to produce hydrogen and was able to solubilize the calcite, and I found that there is high concentration of bicarbonate, and the only source of bicarbonate is only the hydrogen that's being pumped out from the rooting system of this hyacinth bean, and was able to solubilize the calcite, and therefore producing hydrogen carbonate and releasing the calcium. And then I found that there is high concentration of calcium in the system, and it was so amazing for us. And I did not find any problem in publishing out this article in the UK journal, and it was really amazing results for us. As a conclusion, importance of waste management. Waste management should be managed carefully, and we should avoid buildup of heavy metals. We should manage waste in order to improve synchrony, and we can use phytoremediation for calcareous sodic soils, and the roots of hyacinth bean, and hyacinth beans are, I repeat, lubiafin, and this is to less extent white cowpea can produce significant amounts of hydrogen proton during fixation, and this phytoremediation may be an alternative to chemical amelioration of calcareous salt soils. Thank you.
Shukran, Professor Mubarak, for the interesting talk. I think I have to give you a